repeated measures t-test, also known as related sample t-test. Repeated sample are related. Same are the dependent sample t-test. The samples are not independent. The measurements are considered as pairs, so the two samples must be the same size. Same size. Uh, Same size. Okay. The formula is based on the different scores are calculated from each pairs of samples. So t-test, repeated measure t-test equal to d bar minus of mu1 minus sorry mu1 minus mu2 divided by st divided by root of root n, where d is the mean of the difference scores, and n the number of pairs. The degree of freedom is still n minus 1. Actually, mean of the different scores really we have to subtract from this value. First we have to subtract mu1 minus mu2, getting this subtract, that is mu1 from first sample, one sample, mu2 from other sample, subtract, then deduct or minus from d bar. D bar is the mean of the different score. Mean of the different scores. Okay. And the nth number of pairs. N is the number of pairs. This is the standard deviation. Okay. Number of pairs to be reduced by square root. Then how much we are getting? SD is divided by this value, standard deviation. Then how much we are getting? Then keep this value here. We have find this value, then divided by this. Then is the result is the t-test. Okay. The null hypothesis for the repeated measurement t-test is usually that the mean of the different scores d is 0. In the null hypothesis, for the repeated measures t-test is usually that the mean of the different score is scores d is 0. Okay. CA for the repeated measurement t-test. CA, then normally we are going to minus, deduct or subtract alpha value from 1. Okay, equal to mean of the different score d plus or minus, then d alpha divided by 2 pf st root n. We have to reduce the value n sd divided by this reduced root n. How much we are getting n number of pairs here, that one take root, then reduce that value, then sd is divided by this value. Okay, then we got sd divided root n, then we have to multiply with t alpha by 2. Okay, then multiply this. After that we have to add subtract with d, that is mean of the difference score. This is the CI for the repeated measurement test value. Here also T alpha same like before. T alpha by 2. It means, what is the meaning? 5 divided by 2. It means 50, making 50 percentage. TF. T alpha anything divided by 2 means it is making 50 percentage. Taking T alpha 50 percentage. Okay. Two measurements. Two measurements. H naught. H naught equal to mu equal to mu naught. HA equal to mu not equal to mu naught. This is mu equal to mu naught. Mu, when mu is not equal to 0, that one HA. Observations. N x bar S T equal to mod of x bar minus mu naught. Okay, here we have to mu naught reduce mu naught value deducted from x bar. That is the observations equal to D. Okay, and then N x bar S D all are for N also same, for x bar also same, for S also same, D also same. That is mu naught subtract from x bar. Reject H naught if H naught, reject H naught if P of x bar minus mu bar mod of x bar mu naught greater than or equal to D, and then overall is less than or equal to alpha. Reject H of. Even you have to reject. What is the condition? This is the one condition. What? P x bar mu naught deducted from the subtract from x bar, that value must be positive value only. That one equal to D or maybe greater than D, and then that is probability of this, then this total to be less or equal to alpha. Here equal to P mod of x bar minus mu naught divide both side a square n root of a square n is greater than a, here also be. Okay, root of a square n. So n you have to be add that a square value to be add, s value to be multiplied, that s square value divided by this n, how much we are getting. So that one square. Actually a square value divided by n, how much is pair, then squaring that this one mu not deduct from x, that this much value divided by here D also divided by this a square divided by n. First a square divided by n, that is n is the total pairs, then to be reduced that value by root a, then divided by D is divided by this value, how much we got. Okay, then P of Tn minus 1. P of Tn minus 1 is greater than D divided by S square divided by N. That is Tn minus 1 mod is greater than that is D by S square N. This one value what? This. X bar minus mu naught divide S square divide N root of S square divided N equal to Tn minus 1. We have to what we are doing. This is same. Okay. This is same here. So here only what? Tn to be T. Actually, how much we got Na? That one reduced from 1 A. N minus 1 means one sample A. Then that in T one sample how much is greater than. Then comparing samples. Comparing samples. Comparing samples. Comparing samples, the concept of the number of standard errors, that the samples means differ from populations means applies to both confidence intervals and significance test. That is samples going to be comparing here. The concept of the number of standard errors. The concept of the standard error, that the samples means differ from population means applies to both confidence intervals and significance test. Concept of the number of standard errors. Number of standard errors, that the sample means differ from population means. Sample means differ from what? From sample means differ from population means. This is for example population. This is sample means. So different. Mean different. Sample means differ from population means applies to both confidence intervals, both apply to CI confidence intervals and the significance test. The true sample t test is found by weighting the average of the variances. The two sample test, the two sample t test is found by weighting the average of the variance. The two sample t test found by weighting the average of the variance. T equal to x1 bar minus x2 bar. T average variance. The two sample t test is found by weighting the average variances. Okay. The two sample t test. This is the two sample t test. Two sample